Welcome back to Statistical Reasoning. We are going into Chapter 10, Correlation and Regression. It is the last chapter that we will cover in this course. There are two sections that we're going to cover. We are going to cover Section 10.1, which is correlation, and then Section 10.2 in the next video, which is regression. So the first things we need to talk about is the idea of correlation, and what we do is we are going to focus on if there is a linear correlation or a linear relationship between two variables. We will use a coefficient of r to see how well they relate to each other. We will also just focus on, because they're linear, straight line patterns. So first we'll talk about a correlation. A correlation exists between two variables. When the values of one variable are somehow associated with the values of another. So we're trying to see if I change one variable, does it affect, or is there a relationship as I change another, as the other one will change with it. So it could be as one variable goes up, the other one goes up, or maybe the other variable goes down, or it could be something that's totally different, not even linear. So we are going to focus simply on linear correlation. In other words, do they form a linear pattern? They don't always form a linear pattern, they might form something else, but we're going to focus on lines. So here's an example of a scatter plot. You can see that I definitely can see a pattern as it moves up and to the right. So we do call this a distinct straight line or linear pattern. We say in this case that there is a positive linear relationship because I can see that as the graph moves, it is going in an upward direction. So as x increases, so does y. In this case, the straight line is actually even more distinct than the last one. They're more grouped together. But this time, as my x value is increasing, my y value is decreasing. This 4 then gives us a negative linear correlation. But of course, it could be something besides those. We have this situation where they're kind of just all over the place. There definitely is not any type of distinct pattern. And so in this case, we don't have any kind of correlation. Or it could be a non-linear relationship. And in this case, it looks like it's an arc. And for those of you that know your equations, that definitely looks like it's a quadratic. So let's back up a moment and let's look at the values that were underneath each of these shapes. I was mostly focused on the shape to begin with. So we definitely said this was a positive correlation. We can see the positive slope. And notice down here I have an R value of 0.859. In this next one, I have a negative slope. It's going downhill, so you can see that my R is negative. This group is more tightly bunched. And notice on this one that the R value, excluding the negative, is definitely a much higher number. 0.971 is definitely greater than 0.859. In this one where I have my points all over the place, I have a very small R number. 0.074 is a very small R number. Then on the last one, when it tells me I have an R number of 0.330, that is really not helpful because R values are strictly used to measure linearity, and this is not linear. So what it's telling us is if This 0.330 is if I were to try and draw a straight line, what relationship that would be. And I don't know if that's where the line would be or not, but that's what the 0.330 is really measuring for us. So here are all those slides put together. And so we definitely want to make sure we understand that we're just measuring the strength of the linear relationship or association. So this is a poor R score because it is not, I can see that it is definitely not an R pattern or a linear pattern. So we have some symbols that we have to know about. So if we are talking about the linear correlation coefficient for our sample, we use the letter R. If we're talking about it for the population, we use what's called rho, and what it is it's a Greek P. And yeah, that kind of looks like a P. It's supposed to be tilted a little bit, and it's not supposed to come together. That's a little bit better rho, but that is the letter we're going to use. So just like any other test that we run, we have to check for requirements. The sample of paired data, so now we do have two sets of data that we are comparing, and we have to, just like normal, make sure we have a simple random sample. And the other thing we have to think about, maybe a term we haven't said a lot lately, but we do have to make sure it is quantitative data. If one of my list was words, I cannot do a linear relationship with that. No categorical or qualitative data. It must be quantitative. So my second requirement is when I look at the scatter plot, I must see that straight line pattern. If it doesn't give me that straight line pattern, I shouldn't run this test. We also have to be aware of outliers. This test is strongly affected by outliers. And so there what you need to do is, if you do have an outlier caused by an error, you need to remove it. So remove all outliers caused by errors. And if you just did a bunch of errors, you need to recollect your data anyway. The other thing that you might end up doing is, if you have some outliers that are not caused by errors, run your data with the outliers and without it and see how the test changes. So when we find our R value, we are going to round it to 3 decimal places, and we'll use that in our testing. When we go to do our test, we'll do our p-value just like normal. If our p-value is less than or equal to our alpha, then it's saying that there is a linear correlation. If our p-value is greater than our alpha, then there is not a linear correlation.